Hi, I'm Mark Jackson with Cambridge Quantum Computing. Our quantum software development platform, TKET, allows you to easily move from one quantum hardware platform to another. It also finds the most efficient way to implement your circuit, maximizing your performance. Google recently published an interactive routing with TKET tutorial on their Quantum AI site, illustrating how you can use TKET to map quantum circuits and work with generic devices. In this video, I'll be walking you through it. If you'd like to follow along, just go to the URL shown in the description below and download the notebook. If you haven't already, be sure to download PyTicket at the repo in the description below also. So let me now share my screen with you so you can see the notebook. And you should see that right there. So we will begin by installing the module dependencies. Since we're using Google's platform, we will need to first install circ, recirc, as well as a few others. So we just do that by clicking these and this. So now we want to produce a circuit. We'll be doing a 3 regular circuit on Sycamore 23. This is a 23-qubit subset of Google's Sycamore chip, which is easier to work with and presents less hardware-related complications than using the full Sycamore device. But of course, it uses the same gates and compilation. So we click this, and we produce a nice circuit diagram here. And notice we're using this kind of strange indexing scheme. We can think of these as the logical indices, which are indexed 10 through 19. And so now if we do this here, we see the connectivity between the qubits. And again, all these qubits have 3 couplings. So now we can do the same thing for the device, and we see the connectivity here. Notice that these qubits are labeled by the row and column of where they are in the Sycamore device. So we simply tell it that that's the device that we want to use. So now we want to come up with we want to find the most efficient way to implement this circuit and map it into the device that we've chosen. So the first thing that we would do is we come up with a slightly different scheme for indexing. So it's labeled contiguously from 0 to 22 instead of the row column as we were using before. And so then we simply do this. And this confirms that there's a conversion between these 2 different indexing schemes. There's kind of a bug, or a quirk rather, in PyTicket when it comes to labeling with the 2 indices, but we can confirm that we actually have all the connectivity in there using our new naming indexing scheme here. So now we simply do this and this. And we can get an initial map. So this shows all the couplings in the very beginning, and we can decode it back into the original circuit idioms if we would really like. So we see here the row column indexing. Now, what TKET does is it applies these swaps to find the most efficient way to implement the circuit on the device we've chosen. And so the final map will be given by this. And again, we can see that it gets converted back. Indices here. So once we do that, we see that we get a different circuit diagram, and the connectivity is shown by this. And we see that it's no longer just the 3 couplings. We see that there's 1 and 2, and that's because it's now aware of the device that we've mapped this into. And then finally, we can just confirm that these circuits are indeed equivalent just by doing this. And so now that you see how it's done, I encourage you to start using TKET for your own circuits.